Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a sphere having diameter 50 millimeter. This sphere has been cut by a section plane inclined at an angle of 45 degree to the horizontal plane and perpendicular to the vertical plane. That is, an auxiliary inclined plane cuts the sphere at a distance of 15 millimeter from the center of the sphere. So we will find that this will be the true shape of the cut section which will be obtained. That is, a circular cross section we are going to obtain corresponding to the cut section. But since this cutting plane happens to be inclined with respect to the horizontal plane, so the true shape of this cut section will not be available into the top view projections over here. So then we are required to draw an auxiliary inclined plane parallel to this cut section in order to obtain the true shape of the cut section of the sphere over here. And one thing we must remember, that the cut section true shape will be circular in nature, right? Now we are required to draw the sectional front view, top view and the true shape projections of this cut solid over here. Now let us first of all draw the front view and the top view projections of the sphere. So we know that the sphere, whether we view it from any orientation, whether top, whether front, or even if we look at the sphere from the side, we are going to obtain circular projections of the sphere. So in the front view, we have been able to obtain the circular projections corresponding to the sphere having diameter as 10 millimeter over here. So once we draw the circular projection, that is the front view projections corresponding to the sphere onto the vertical plane, now we can divide this sphere into 4 parts to begin with, so that the two mutually perpendicular diameters of the sphere we are able to evaluate, and the center point corresponding to the sphere we are also able to evaluate. So these are the front view projections. Now let us draw the top view projections of the sphere. So we know that even when we are going to look at the sphere from the top, so we are going to obtain circular projections having diameter equal to 50 millimeter corresponding to the sphere. So the front view projections will also be circular and the top view projections will also be circular. Now we have been provided with the information that this sphere has been cut by a section plane which happens to be inclined at an angle of 45 degree with respect to horizontal plane and perpendicular to the vertical plane at a distance of 15 millimeter from the center of the sphere. So here again we can draw an arc or a circle over here such that the radius of the circle will be equal to 15 millimeter or the diameter of the circle will be equal to 30 millimeter. So this is just a constructional circle that we have drawn such that at a radius of 15 millimeter from the center, this is the center of the sphere, a cutting plane which is inclined at an angle of 45 degree with respect to the horizontal plane. So it will be cutting the sphere into this orientation. Now we can check the radius at which this cutting plane is going to intersect this arc over here. This is equal to 15 millimeter. So now having obtained this cut section, now we can see that this is the remainder portion of the solid which is left behind. Now we can check this portion of the cut section we have been able to obtain onto the sphere. We can check this portion of the cut section we have been able to obtain on the top surface of the sphere. Now we can divide the sphere into 12 equal parts as well, but even when we divide the sphere into 12 equal parts, most of those sectors which are separated by 30 degree, they will not be intersected by this cutting plane. So we will not be having enough points of intersection of the cutting plane with the different sectors that we could have generated over here. So in order to obtain the sectional top view, which will be looking like an ellipse over here, we know that the cut section of the sphere will always be a circular portion. So here we have obtained a circular true shape portion corresponding to this cutting plane intersecting with the sphere into this orientation. Now even if we divide this sphere into 12 equal parts, we will not be able to obtain the appropriate number of points through which we will be able to obtain the elliptical projections corresponding to the sectional top view of this cut section over here. So what we are going to do, just like as it is shown over here, we are going to use the principle of slicing over here. So we know that there are 2 points which are available corresponding to these extreme points which will be available in the top view projections over here. One point, it will be projected here. Another point will be projected onto this diameter over here. But in between, now we have to divide this cutting plane into this orientation by using the method of slicing over here. That is, we are going to divide this portion of the inclined cut section by using the slicing. That is, different slices we are going to obtain over here, so that corresponding to every slice, 2 points they will be available with us. So between these 2 points, as we have already discussed, 2 points they are already available. So in between 6 slices I am going to obtain over here. We can check slice number 1, slice number 2, slice number 3, slice number 4, slice number 5 and slice number 6. So in between, corresponding to these 6 slices, we can see 6 rings will be there. If 6 rings we are going to have over here, so corresponding to every ring, 2 points we are going to obtain into the sectional top view over here. So that is how 14 points we are going to obtain into the front view projections, 14 points we are going to obtain into the top view projections. So a better elliptical construction in the sectional top view would be obtained, and a better construction of a circular projection which will be involving 14 points of the cut section. So it will be possible into this particular case. So now, as we have discussed, there are 2 extreme points. So let us start from this point. So this point we can label as point 1. This point will be point 2, 3, 4, 5, 6, 7 and 8. And then again 9, 10, 11, 12, 13 and 14. So in the front view, we are going to obtain 14 points of intersection of the cutting plane with different rings or different slices which we have arbitrarily chosen over here. You could have chosen 5 intermediate rings, but in order to obtain more accurate construction of the elliptical construction in the sectional top view and the circular construction in the true shape projections over here, so more the number of points, so better will be the accuracy of the construction over there. So the 14 points available with us, they are 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash, 13 dash and 14 dash. Now we can check corresponding to every ring or the slice we have added over here, couple of points will have to be located into the sectional top view and into the true shape projections over here. So now, having identified 14 points of intersection in the front view projections, let us locate all of these 14 points in the top view projections over here. So from the point 1 dash, if we draw a vertical projector over here, now we will find that it is going to intersect with this diameter into the top view at this position. This will provide us with the location of the point 1 into the top view projections over here. Now, as we have discussed that these points we have located onto the cutting plane, so that these points, they should be located at approximately equal distances from each other. So now, corresponding to different points, now we can check these are the diameters of different rings. Even we have differentiated between different rings by choosing different colors over here. So this is ring number 1. So we call this ring number 1 as ring A. So corresponding to the ring A, there are 2 points of intersection which are available with us over here. Points 2 dash and 14 dash. But these points, they are not visible to us from the front view projections. Why? Because these points, if we are going to look from this side, this point and this point, they have been overlapping with each other. So how do we obtain these 2 points into the top view projections? Now, we know the diameter of the ring corresponding to the location of this particular ring number 1 or slice number 1. We know the diameter of this slice or diameter of this ring onto which these 2 points, they are located. Now we can check these 2 points, they are located 2 dash and 14 dash into this orientation. 1 point will lie here, 1 point will lie here. Now, since we are looking from the perpendicular direction, so from the front side, we'll not be able to look at the distances between these points in the top view projection. So how do we obtain the distances between these 2 points in the top view projection? Corresponding to the ring number 1, that is ring A. So this is our ring A, you can check. Ring A. So corresponding to this diameter, we have drawn a circular construction over here having the same diameter as that of the ring A over here. Now, from the points 2 dash and 14 dash corresponding to ring A, we have drawn a vertical projector line onto the top view projection of the ring A, such that one of these 2 points of intersection of this vertical projector with the ring A becomes point 2. The other point on the other side of this diameter, this intersection provides us with the location of the point number 14 over here. We can check it out. One point will be located here, another point it will be located over here. Now, from the points 3 dash and 13 dash, this is ring number 2. So we'll call this as ring number B. So different color we have chosen over here corresponding to ring B. So we know that the 2 points of intersection which are available with us corresponding to ring number B, they happen to be 3 dash and 13 dash. So what we are going to do from the front view again, because these 2 points, they were lying in the perpendicular direction to the observer. So we are going to get 3 dash and 13 dash lying onto the same point in the front view projection. So how do we obtain these 2 points in the top view projections? Now we know corresponding to the location of this point, that is 3 dash and 13 dash, we know the diameter of this ring B. So once we know the diameter of this ring B, now this ring B will be constructed using the same diameter into the top view projections over here. So this is our ring B. Now from the points 3 dash and 13 dash, again we are going to draw a vertical projector so that this vertical projector should be intersecting with ring B at 2 points over here. This point will be labeled as point 3. This point will be labeled as point 13 over here. So we can check this point we have labeled as point 3. This point we have labeled as point 13 over here. Now similarly, here we have ring number 3 corresponding to which again 2 points of intersection, that is 4 dash and 12 dash, they have been obtained onto this cutting section over here. So corresponding to the third ring, that is ring C. So a different color we have chosen over here. So now corresponding to this ring C, the cutting plane is intersecting the sphere at 2 points 4 dash and 12 dash. So now we know the diameter of the ring number C as well. So corresponding to this diameter of the ring C, now another top view circular projection of the ring C we have drawn. We can check. This is ring C over here. So corresponding to ring C, we have got 2 points of intersection, 4 dash and 12 dash in the front view projection. So how do we obtain these points into the top view projections? From points 4 dash and 12 dash, we'll draw a vertical projector line so that this vertical projector line should be intersecting with ring C at 2 points. So these are the 2 points over here. This point happens to be point 4. This point happens to be point 12 over here. So this way another couple of points corresponding to the section top view elliptical portion has been drawn over here. Now there are another couple of points 5 dash and 11 dash corresponding to the fourth ring, that is ring number D over here. That is the 2 points of intersection we will be able to obtain when we are able to locate points 5 and 11 into the top view projections corresponding to the ring D. Now again we know the diameter of the ring D, which has been shown by a different color. Now fourth ring we have drawn. So fourth ring is ring D over here. This is ring number D. Now 2 points of intersection, they are available with us in the front view projections as 5 dash and 11 dash. So from 5 dash and 11 dash, again we have drawn a vertical projector line and we will extend it up to the point where it will be intersecting with ring D at this point and this point over here. So this point will be point number 5 and this point will be point number 11 over here. Next we have got another couple of points 6 dash and 10 dash corresponding to the fifth slice or ring number E over here. So now once again we have to locate these 2 points 6 and 10 into the top view projection. So now corresponding to the ring E diameter, another circle we have drawn onto the top view projection such that if we draw a perpendicular projector from the point 6 dash and 10 dash, now this vertical projector drawn through the point 6 dash and 10 dash, it should be intersecting with ring E. So this is our ring E. So it should be intersecting with the ring E at these 2 points. So this point will be labeled as point 6. This point will be labeled as point 10 over here. And finally we have got ring number 6 and the corresponding points of intersection, they happen to be point 7 dash and 9 dash into the front view projections over here. So now once again we know the diameter corresponding to the ring F over here. So corresponding to this diameter of the ring F, again and this is the circular projection which is coinciding with the circular projection of 50 millimeter diameter, which is corresponding to the outermost ring which we had originally drawn over here. So from 7 dash and 9 dash we have again drawn a vertical projector line, and wherever this vertical projector line intersects with the outermost circle over here, circle F is the original circle which was drawn having diameter is equal to 50 millimeter. So wherever it intersects with the outermost circle over here, point 7 and 9 they have been obtained over here. And finally 1 point was there corresponding to this extreme point of intersection of the cutting plane with the circumference of the sphere. So this point happens to be point 8 dash. So once we draw perpendicular projection from 8 dash onto the outermost portion of the circular construction having diameter 50 millimeter, we obtain the point 8 over here. So this way, by using the slicing mechanism, multiple points of intersection, that is 14 points of intersection, we have been able to evaluate into the front view projections. All of these multiple 14 points we have been able to obtain into the top view projections as well. And now once we join all of these 14 points into the top view projections, now we find that this circular portion of the cut section, since it is inclined with respect to the horizontal plane at an angle of 45 degree, so the top view projections of the circular cross section, which is obtained by cutting off the sphere by this inclined cutting plane over here, it will be appearing as an elliptical cut section into the top view projections over here. And once we do the sectioning, so we obtain the apparent shape sectional top view projections corresponding to the cut section, for which 14 points of intersection they had been located into the front view and into the top view projections over here. So since we have been able to draw large number of points into this elliptical construction, the construction that is obtained over here, it will be an accurate construction of the ellipse over here. Now we are required to obtain the true shape projections corresponding to this cut section over here. And we already know that whenever a sphere is cut by a cutting plane inclined in any orientation whatsoever, so the cut section obtained will be circular in nature. So this true shape we already know, but we have to just verify that whatever true shape we are going to obtain, it should be a circular cut section true shape over here. So in order to obtain true shape of this cut section, observer will be looking at the cut solid into this orientation. Now we are required to draw an auxiliary inclined plane x1 y1, which will be parallel to this cutting plane or the cut section over here. So now from all these 14 points of the cut section, we have drawn perpendicular projectors onto this AIP x1 y1, and now the auxiliary plan projections which we are going to obtain onto this AIP x1 y1. These auxiliary plan projections will provide us with the true shape of the cut section corresponding to this section sphere over here. So let us obtain all of these 14 points into the auxiliary plan projection view over here. So now the first point available over here is point 1. So please check. From point 1, if we measure the distance of point 1 up to the XY reference line. So if we measure this distance of point 1 from the XY reference line, so from the projection point 1 dash onto this projector, if we mark the same distance, the point 1 1 will be obtained into the auxiliary plan projection over here. Similarly, the next 2 points they are available with us, they are 2 and 14. So now what we are going to do? We are going to measure the distances of the points 14 and point 2 from the XY reference line. Now corresponding to the second projector passing through 2 dash and 14 dash onto this projector line, if we plot both of these distances, so we can check distance of 14, it has been plotted here. Distance of point 2, it is distance of point 2 over here. It has been plotted appropriately in front of the auxiliary inclined plane x1 y1. So the 2 points 21 and 14 they have been appropriately obtained into the auxiliary plan projection over here. Similarly, the next 2 points, they are 3 and 13. So now we are going to measure the distances of points 13 and 3 from the XY reference line. From these projection points 3 dash and 14 dash, there is third projector line which is emerging. So onto this projector line, points 13 1 and 3 1 will be appropriately located at distances corresponding to distance of point 13 from the XY reference line and point 3 from the XY reference line. So this way another couple of points 3 1 and 13 1 points they have been located over here. Then the next set of points which are available with us, they are 4 dash and 12 dash. Now we are going to measure distances of the points 4 and 12 from the XY reference line. So the distances of points 4 and 12 once we measure, So from the projector line emerging from the points 4 dash and 12 dash, we are going to mark these two distances over here, and we will be obtaining the points 12, 1 and 4, 1 in the auxiliary plan projection view over here. Now the next set of points is 5 dash and 11 dash. So now we measure the distance of the point 5 from the XY reference line and the distance of point 11 from the XY reference line. Now from the projector line emerging from the points 5 dash and 11 dash, that is this projection line, we are going to mark the distances of point 11 and point 5 over here. So point 11, 1 will be located over here and point 5, 1 will be located over here. Next two points, they are 6 and 10. So corresponding to the point 6 dash and 10 dash, we are going to measure distances of points 6 from the XY reference line and the distance of the point 10 from the XY reference line. So once we evaluate the distances of the points 6 and 10 from the XY reference line, now onto the projector line emerging through the points 6 dash and 10 dash, we are going to mark the distance of the point 10 here, distance of the point 6 will be marked over here. So points 10, 1 and 6, 1, they have been evaluated into the auxiliary plan projection view. Now the next two points available with us, they are 7 dash and 9 dash. So now we are going to measure the distance of the point 7 from the XY reference line and point 9 from the XY reference line. So once we measure the distances of the points 7 and 9 from the XY reference line, now onto the projector line emerging from 7 dash and 9 dash, it is this projection line. So onto this projection line, if we mark the distance of point 9, if we mark the distance of point 7, so the 2 points 9, 1 and 7, 1, they will be located over here. And finally, the last point available over here is point 8 dash. So now we will be measuring the distance of point 8 from the XY reference line. Now this distance we have to plot onto the projector line emerging from the point 8 dash. So it is this projector line. So this distance ahead of the plane, we have to mark it out over here. So point 8, 1 will be located appropriately into the plan projection view. So now we can see into the auxiliary plan projection view, we have been able to obtain the location of all the 14 points corresponding to the cut section. So now if we join all of these 14 points, we observe that the true shape of the cut section happens to be a circular cross section over here. So this is what we were already knowing, that is, whenever we cut a sphere in any given orientation, the true shape of the cut section that will be obtained, it will be circular in nature. So having obtained the true shape projections of the cut section, we have carried out the sectioning and we have marked this shape as a true shape projections of the sectioned sphere, which has been cut by an auxiliary inclined plane at an angle of 45 degree with respect to the horizontal plane at a distance of 15 millimeter from the center of the sphere over here. So now we have been able to obtain the sectional front view projections of the sphere, sectional top view projections of the sphere, and the true shape projections of the cut section when the sphere is cut by an AIP inclined at an angle of 45 degree with respect to the horizontal plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure. How do we evaluate the sectional front view, sectional top view, and the true shape projections of a section sphere when the sphere has been cut by an auxiliary inclined plane, inclined to the horizontal plane. So we will be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures. So thank you very much. Thanks a lot.